आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
We are extremely happy and honored to receive a conversation from Dr. Saikat Biswas. He will now be introducing himself and his academic journey as well.
Hello, I am Saikat Biswas. I am an associate professor at Bose Institute presently. I did my PhD from Variable Energy Cyclotron Center, which is commonly known as VECC, which is also situated in Kolkata, but my degree is from University of Calcutta. After that, I was postdoctoral fellow in GSI Darmstadt, Germany, and then I received the prestigious Ramanujan Fellowship from DST, SARB, and then I again came back and joined VECC for some time. Then I was also 2 years in NICER as a scientific officer, and then I joined Bose Institute.
Dr. Biswas will now briefly introduce his area of research.
I am basically experimental high energy physicist working on experiments, different experiments. Now I am going to talk about the facility what is India is going to build in Germany. Its name is FAIR, Facility for Antiproton and Ion Research, and India is one of the important country to build this FAIR facility, and I will be discussing more about upcoming FAIR facility.
Dr. Saikat Biswas is requested to say a few words about FAIR and will also speak on the role of India in this project.
As I told, the name FAIR stands for Facility for Antiproton and Ion Research, which is currently under construction in Darmstadt, Germany, which is very close to Frankfurt airport. And India is one of the main country among 9 countries all over the world, but mainly from Europe, and India is only non-European country who is basically building the FAIR facility. And in many outreach program, I talk about that India is building FAIR facility. So why it is very important for us, a person from Bose Institute, because this FAIR project is from Indian aspect. FAIR project is basically a DAE DST project. DST means Department of Science and Technology, and DAE is Department of Atomic Energy. And FAIR is a joint project of DAE and DST, and DST is the nodal of this international project, and Bose Institute is identified as the shareholder to build this FAIR facility, and the director of Bose Institute is basically the shareholder for this project. We have twofold responsibility. One, India is building the FAIR. That means to build the FAIR, India is not giving only the money to build the FAIR facility, but India is giving some items which is called the in-kind items, what will be used to accelerate in the accelerator facility. This is number one. And number two, we are also coordinating the scientific part, like after building this fair facility, there will be 4 experiments like CERN experiment. In CERN, there are 4 experiments, ALICE, ATLAS, CMS, LHCb, where also we are taking part in one of the experiments, ALICE. Similarly, in FAIR, there will be also 4 experimental pillars. The names are APPA. APPA stands for Atomic and Plasma Physics, New STAR, which is basically nuclear physics, and then comes CBM, compressed baryonic matter, and there is another project called PANDA. This CBM, which is one of the main experiment where many institutes from India, including Bose Institute, we are participating. Many students, faculties, they are working for CBM, which is an upcoming experiment in the field of high energy nuclear physics collision experiment. And also in New STAR, experimentalists from India, they are working. So from Bose Institute, we are coordinating with them as well. The funds are released to these institutes from Bose Institute. These experiments coordination also are being done from Bose Institute. Before experiment, I will talk about the accelerator facility. Why we are building this facility? Because you can ask me that at CERN there is already one facility of accelerator is there. Now there is a difference between the accelerator situated at CERN and what we are going to build at FAIR, Germany. Thing is that at CERN, the experiment is the collider experiment. The accelerator size is very big, large, that's why its name is Large Hadron Collider. It is very large. Its circumference is 27 km. Whereas in FAIR, the size is not so big. It is only 1 km. But what is the difference? Difference is that those experiments at CERN, they are collider experiments, means 2 beams are coming to each other and they are colliding. And at FAIR, we are going to organize the experiment which is fixed target experiment, means the beam is coming and hitting a target and then many particles are being produced. Now, why we are doing like that? Because here, as I told, one beam is coming and hitting the target, the intensity of beam is very much here at FAIR. I can give you an example. At CERN, currently the collision rate, particle rate is 50 kilohertz. You can imagine hertz is 1 particle per second, means 1 hertz. So it is 50 kilo, 50 into 10 to the power 3 particle per second. But here the rate will be 1 megahertz per centimeter square, means in 1 centimeter square area, 1 megahertz, 1 into 10 to the power 6 particle will hit. So particle density will be very high. Why we are doing like that? Our basic intention is to study the phase transition of something. Why I am calling something? You know the phase transition of common phase transition like water to vapor or water to ice, ice to water, such kind of phase transition we all know. But we study another phase transition which is particle to another phase of matter, what we call the quark-gluon plasma. You know the matter consists of proton, neutrons and electrons. Nowadays we know protons are also divisible. So protons are not the unit, you can say. So protons are divisible, they are made with quarks. But these quarks cannot stay freely. These quarks are bound and they are making in a bound state and they are staying as proton. In proton there are 3 quarks, 2 up quark, 1 down quark. Similarly, neutrons are also consist of 3 quarks. Now, when these particles are collided at very high energy, then they can be broken. Another way we can break them, we will not increase the energy to a very high extent, but what we will do, we will compress this particle at a very narrow space. Then also these protons and neutrons, they will break into its constituent quarks. Now this phase, one fireball kind of situation will take place when we collide two particles, and this is also one kind of phase transition. That means it is from hadronic phase where we can see protons and neutrons, and another is the phase of quark-gluon plasma where we cannot say there is proton and neutrons, but we can say there is a soup of quark and gluon, and it is a plasma kind of phase. So that is why its name is quark-gluon plasma. Now this phase transition can take place in two ways, as I told. One, I will not take density a very large extent, but energy will be very high, what is done at CERN. That is why the circumference is very big, two beams are coming to each other, so energy is very high. It is very high temperature, TeV energy, you have heard about TeV energy. So the energy is high, density is low, that kind of experiment, and that kind of experiment where this phase transition can occur is done at CERN. But in FAIR, we will not take the energy to a very large extent, but the density will be very high, and then also we can make this kind of phase transition. So you can understand the difference. That is why the FAIR is a unique opportunity for Indian scientists as well as scientists from all over the world to work and study for science. Now I talk about one aspect, like I talked about high energy thing. There is also, as I told, there is new star experiment where the energy is not so high and the physics goal is also different. There are many scientists in India, for example, in TIFR we have our collaborator who are working in new star experiment, in VCC, in Punjab University, in IUC Delhi. So these institutes are involved in new star experiment as well at FAIR. So for us, for Indian scientists, this facility is extremely important for future scientists, for young scientists who are coming up in this field. Now I will talk about what we are doing. As I told, we are mainly currently working to build the facility, and for that you need several instruments. I can give you some example. As in-kind item from India, we have already sent, I will not use the term supplied, I will tell sent vacuum chamber, which is very important item. Vacuum chamber means you have a chamber made by thin metal, thin or somewhere thick metal, but you need the leak rate very low. That kind of vacuum chamber we built in a company at Bangalore called Vacuum Technique. They built 58 such vacuum chambers. We have sent it to FAIR. They have well accepted, and India got the certificate for this as well. Another component is called power converter. ECIL Hyderabad, which is also a DAE institute, they built 454 power converter, all are sent to FAIR. So they are also well accepted. Then we are going to supply another important component, that is called beam stopper or beam catcher. Like when you are colliding some beams and let us say you want to stop some beam, then you need some device which can stop that unwanted beam, and for that we will build 3 beam stopper, and this is one of the most important item from India because its design is also done in India. CSIR CMERI Durgapur, they have designed along with FAIR Germany and Bose Institute VCC experts, and the designs are made, and after that there will be 3 beam catcher, and one company at Kanpur called the Trident, they are building this 3 beam stopper, and we will send very soon the first module which is used as prototype. After that rest 2 we will send. So this is one component, and we have recently sent another component called IT diagnostic cable, which will be used to collect the signal in the experiment. So those cables are also built in one company called Shikem in South India, Chennai, and we have also delivered more than 900 kilometers of such cable. So with this we are working with our industry. At Bose Institute in last years or it was in 2023, I think, we organized a meeting which is called Indian Industry Outreach Meeting kind of thing. So 16 industries from India came here, met here. We discussed 2 days. Experts from different institutes who are working in engineering aspect, they came here and also delivered lecture from fair. Some experts were here. So we organized this fair industry meet that was in Bose Institute only. And most importantly, I want to mention, every year there are 2 fair council meetings, mainly to discuss the high level. This is the high level meeting to discuss about the policies of to build this fair. Now, the 42nd fair council meeting was held in last year, 2024 December 3rd and 4th, here at Bose Institute, which was the first time outside fair Germany. So that is, I mean, I will be very proud because I was one of the organizers to organize this meeting here, and our director invited them to come here and they accepted that invitation, and then we organized the meeting in Bose Institute. So that I wanted to mention because that was really remarkable job. DST also already know about these things because that time DST people joined online because they could not attend that meeting, but it was very nice.
We are thankful to Dr. Saikat Biswas for sharing the wonderful information about FAIR with us. Thank you so much.